Hello. Today's video we are going to focus on factoring using GCFs, which is the greatest common factor, and grouping, and we like to use grouping when we have polynomials with 4 terms. The GCF will help us simplify a trinomial or something so that we can use previous skills to help us factor that. So I do want to spend some time reviewing when we did quadratics, when we factored them. I won't go in depth like this in class, so if you don't remember how to do this, it might be a good idea to watch the video. The first thing we do when we have this and when we need to factor is we want to identify our A, B, and C. And remember that that's taken from our equation itself. So our A value is the number in front of the x squared. In this case, it's 2. Our B is the number in front of our x. In this case, it's -5. And then our C is our constant. It's that number that doesn't have a variable. So in this case, is -3. From here, we want to use our x, where on top we do A times C. So we're going to multiply those two. And at the bottom, we have our B. So A times C, 2 times -3 is a -6. And at the bottom, we have a -5. So we want two numbers that when we multiply them gives us our number at the top, and when we add them gives us our number at the bottom. Now, I know that these are going to be opposite signs because the product is a negative, and the only way to get a negative product is when one is positive and one is negative. So since I need a -5, I'm going to say this is -6 and +1. -6 times +1 gives me the -6, and when I add these two, it gives me my -5. From here, I need to do so this is the X box method, so I am going to draw out my area model. But remember, what's different about this one is that instead of starting on the outside and finding the inside, we are now going to have the inside and we need to find the outside. So I am going to, in this first box, it's our first term. So we have 2x squared. In our last box, we have our last term, so -3. In our two diagonal boxes, we're going to have our two terms. Now, remember, it doesn't matter where you position them. It'll ultimately give you the same factors. So I'm going to do -6, and I need to add an x. And then I'm going to say +1, and again, add the x. From here, I want two terms. So I'm going to pick these two, the 2x squared and the -6x, and I need to pull out the GCF. What do they have in common? So here they have a 2 in common, and they both also have an x. So then what do I multiply by 2x to get 2x squared? And that's kind of what we've been doing with division. So now I have this x. So now what do I multiply by 2x to get -6x? That would give me the -3. What do I multiply by x to get a +1x, which is +1? Therefore, my factored form would be 2x + 1 and x - 3. Since this is multiplication, it doesn't matter which one you position first. It's like saying 2 times 7 and 7 times 2. It'll give you the same thing. So let's do another one here, and I'm going to do this one a little bit different. So again, I'm going to find my A, B, and C. My A value is 1, my B is -3, and my C is -28. So A times C is -28. And my B is -3. So again, I want two numbers that when I multiply them gives me the top and add to the bottom. So again, I know the numbers are going to have different signs because the product is a negative. So I know that 7 times 4 gives me 28. And since this has to be negative, the bigger number would be negative here. Now, usually we go into the box here. But if you remember, I very, very shortly I made like a note in class. If your A value is equal to 1, +1, not -1, only if it is equal to a positive 1, you can take these two and they become your part of your factor. So I am going to take my x and my x here. I'm going to say x minus 7 and x plus 4. Remember, you can only do this when a is equal to 1. When a is equal to 1. But just to show you that that's what you would get, I am going to do the box for this one, and then we'll do a couple where we don't have to double check. So in the first box, I'm going to put my first term, which is x squared. My last box is my last term, that's c value, which is negative 28. Then I'm going to do negative 7x and then positive 4x. I like to keep my signs. So what do these two have in common? That's going to be an x, so then I need another x here. X times a positive 4 will give me that, and then x times a negative 7 will give me that there. Now I would have pulled these two out and gives me my factors. So remember, it is only when a is equal to positive 1. You might want to make a note of that. Only when it's equal to a positive. The negative won't work this way. So let's do another practice problem. All right, here we go. So find again my a, b, and c. I would get 1, negative 4, negative 5. A times c is negative 5. B is negative 4. I want two numbers. Now this is another reason why I like to put my signs there so that when I transfer them over, I don't forget it. You notice that a is equal to a positive 1 here. And when that's the case, I can just fill it in as x minus 5. And then x plus 1. So we have one more example here. You can pause it and try it on your own. This one is set up a little bit different. You notice that we only have two terms here, where we had 3 in every other one. So my a is going to be the number in front of x squared, which in this case is 1, which is a good sign for us. But I don't see my b value. Remember, my b is always attached to the x, and I don't have that term here, so I am going to say it is a 0. And then my c is negative 16. So a times c is negative 16, b is 0. Since my b value is 0 and I am adding to get that, I know that these two numbers need to be opposites of one another, meaning they're the same number with opposite signs. So since this is a 16, I know that I can do negative 4, positive 4. When I add those two, it will give me a 0. Now, it just so happens that the examples I picked, they were always negative. It's not always going to happen like that. You might have a positive number, and then you know that these two have to have the same sign, whether it be positive, both positive, or both negative. So let's just finish this one up. Minus 4 and plus 4. Remember, you can go from here to here only when a is equal to a positive 1. Only when a is equal to positive 1. Okay, so let's start into the using GCFs to factor. Now, when you look at this, if I were to ask you to find my a, b, and c, we know that a goes with x squared, but here we have an x cubed, and we go down from there. So sometimes you'll have something like this. It doesn't mean that you can't factor it. The first thing I want to notice is that every term here has something in common. So we're going to use that to simplify it. We're going to pull out the greatest common factor. Every term here has an x. So what I want to do is I want to start off by factoring out the x itself. So simplifying that by pulling out the x. When I do that, I get x squared minus 4x minus 5. So it's x times that. If I were to distribute this, I would end up with my original term here. So now I have a green and I have a pink. This is still the same problem, but now looking at just my pink, I can use this to factor and simplify even more. So I am going to do so. You notice if you peek ahead, we already did it here. So I would get, this is equal to x, and then x minus 5 and x plus 1. Now in this one, I cheated a little bit because I had already solved it, or we had already solved it up here. But this is essentially what we're doing. We're going to turn something that we don't know into something more familiar so that we could work with it like this to get our simplified factored answer. Let's look at this one. Now, if you think that you can get started, go ahead and pause the video and attempt this one on your own. If you're not quite there yet, I want to do the same thing to this one that I did with this one. Remember that this here was my GCF. It was something that every single term had in common. So looking at this one, what would our GCF be? What is something that every single term has in common? I noticed that they all have x's. So this has 4, 3, and 2. I can pull out the x squared because all of them have it. I also noticed that this is 5, 30, and 45. Each one of these terms is divisible by a 5. So I am also going to pull that one out. What I am left with here would be, so if I had 5x to the 4th and I pulled out a 5x squared, I would be left with x squared. If I had a 30x cubed and I pulled out a 5x squared, I would be left with plus, so 30 divided by 5 would be 6. And I had 3 x's, I pulled out 2, so I'm left with 1x. And if I had a 45x squared, pulled out a 5x squared, 45 divided by 5 gives me 9. And x squared, pulled out x squared, I don't have any. And I get this. So for a second, I am going to leave my GCF to the side. Now I still have to bring it in, but I'm going to forget for it for a second, just so I could factor these terms here. I'm going to start off with finding my ABC. Now, if we're lucky, if A is 1, then we get to just do this part here instead of doing the box 2. So A is 1, B is 6, C is 9. Since our A is 1, we only have to do the X part to find those two numbers. So A times C is 9, B is 6. I want two numbers that when you multiply them together gives you 9, but when you add them gives you 6. And it would be positive 3 and positive 3. So now, I can write this as x plus 3 from here, but then I also need to bring in my GCF. So my final answer would be 5x squared, which was my GCF, plus my 2 factors, like this. Now, you could leave it like that if you want to, but because I want it to be as pretty as possible, I noticed that these two are the same. Now, I can condense that so that I get my GCF x plus 3 squared. When you have the same thing, you can condense it and put a square. For example, if I were to ask you to expand this, you would give me that. It's just a lot shorter to write it this way. And that is factoring using GCS. The first thing you want to do is look for a greatest common factor if you have it and pull that out. What you are left with, you then want to see if you could factor it or not. If you can't factor it, you don't have to use the quadratic formula. You just leave it as is. Your answer might end up something that isn't factorable, and that's okay. If it is factorable, then you factor. Okay, and the last thing for today's video is going to be factoring by grouping. So when you look at these, you might be taken back a bit because everything that we've factored so far has been trinomials. And now I'm giving you a 4-term polynomial, which is a little bit scary the first time around. We are going to factor by grouping, meaning we're going to group things together that are within this polynomial. So when we have 4 terms, we want to group them into 2 sets of binomials. One here, and then one here. Now, these parentheses don't mean multiplication. We're not multiplying them. I just want to separate the two. The sign, I'm including it because I want to make sure that whatever I pull out, when I pull out the GCF, has a sign included and is taken from both of them. Sometimes if you don't include the sign, you might forget and then you'll get stuck. So we are going to keep using the greatest common factor when factoring by grouping, but now we're going to take it from just the pairs instead of the entire polynomial. So looking at this one, x cubed minus 2x squared, what do they have in common? Well, they both have an x squared. So when I pull that out, x cubed, pull out x squared, I am left with an x. 2x squared, and then I take out that x squared, I am left with minus 2. So for the first one, I have simplified it as much as I can. Now I'm going to look at the next one. What does negative 9x and 18 have in common? We could say that they have a 9, but I'm going to get rid of the sign because I needed to have something in the front. So I'm going to get rid of that, and I'm going to say that they have a negative 9 in common. So negative 9x divided by negative 9 gives me just the x. Now positive 18 divided by negative 9 is going to give me a negative 2. The sign changes because you're dividing by a negative. Now, to get here, to figure out whether or not you need to pull out the sign, it might take a little bit of practice, so it's okay. But what you want to see at the end is that you have the same term written in from both pairs. So each pair gives you the same binomial, which in this case is this x minus 2. So you're going to pull that one. Since they both have that in common, you can now write x minus 2, and then you combine what is left over, which is x squared minus 9. You notice that if I were to separate the second binomial, so if I take this and I separate it, that term would be to both of them. You bring down what they have in common and you combine what is left over. So it might look like we are done, but we need to see if we can factor this anymore. So I am going to do my A, B, and C. A is 1, B is 0, and C is -9. And I'm only doing it with this one because it has the x squared here. This one is already as simplified as I'm going to get it. I'm only doing this one. So up top, I get -9. At the bottom, I get a 0. So I want two numbers that when I multiply them gives me the top, but when I add them, they cancel out. So they have to be opposites of one another, like -3 and +3. So if I were to rewrite this here, I would have x minus 3, x plus 3, and bring down my x minus 2. And that's it. So I took my 4-term polynomial, I broke it up into 2 pairs, into 2 binomials. Looking at each one individually, I pulled out the GCFs, like that. I then took it should be the same thing. I took that and I combined what was left. So I took my blue and I combined my green. Again, these should be the same. If they're not, if one's negative and one's positive, try pulling out a number that has that sign that you're missing. Once here, I needed to make sure that this quadratic was as simplified as it could be. And in this case, it wasn't, so I factored it. The reason why I did this one up here when we were reviewing was so you could see this here. So you saw here we had x minus 16, which we were able to factor out. The same thing would apply with this x minus 9. All right, so here's another example. Go ahead and try it on your own. You can pause it and then see how you did. All right, so I'm going to start off by grouping. And look at the first one, x cubed plus 5x squared. They both have an x squared in common. And I would be left with an x plus 5. That means that on this side, I want to get an x plus 5 also. So I just keep that in mind when I go into pulling out a GCF. Here I can pull out a 4 or a -4. But since I want it to be an x plus 5, I am going to pull out a -4. And I'd be left with the x. So a -20 divided by a -4 would give me this +5, which is what I wanted. I drop what they have in common, which is the x plus 5. And I combine what is left over, which in this case is x squared minus 4. So it might look like we're done, but I still have a quadratic that I need to check whether or not I can simplify doing this here. So I'll get -4 and 0, which gives me -2 and +2. Again, this is just like one of these. They won't always be like that. The next one we do won't be like that. So I would get x plus 5 and then x minus 2 and x plus 2. You notice that this is a by, which we know how to multiply. So if you wanted to check your answer, you can multiply this out and make sure that you get that right there. Okay, so our last couple of problems here. I would recommend you guys attempt these on your own. I am going to go through it, but this is a good place to pause and test your own skills. Okay, so what does x cubed minus 5x squared have in common? They both have an x squared. And I am left with x minus 5. So I know that when I go into the next one, I want to end up with an x minus 5 here. I have a positive 6x and then a minus 30. So since I already have the minus sign, I am just going to pull out the plus 6. So 6x divided by 6 leaves me just the x. Negative 30 divided by a positive 6 gives me that negative 5 that I wanted. I'm going to drop what they have in common, which is x minus 5, and combine what would be left over, which is this x squared plus 6. Now I have a quadratic here. I need to check if it is factorable or not. So my a is 1, there's no b, so that would be a 0, and then my c is 6, so 1 times 6 is 6. So I want two numbers that when I multiply them gives me the 6, but that they are opposite of one another and gives me the 0. You could sit there and try to think of something, but I will tell you that this one is non-factorable, meaning there's no numbers that satisfy that. So my final answer would just be this. Like I said earlier, if it's not factorable, you don't have to use the quadratic formula. You can just leave it like that. We just want it in factored form. So if you can't factor it, then don't try to do anything else. You just leave it like that. And our last one. So again, this one is nice because they're all the same sign. So this has a little bit of bigger numbers that we're looking at. So 3x cubed and 18x squared, what do they have in common? Well, I can pull out a 3, and then I can pull out an x squared also. So 3x cubed divided by 3x squared leaves me just the x. 18 divided by 3 gives me a 6. And then if I pulled out the x squared, then that's all I get. Now I keep in mind that I want this plus 6 on the other side also. So here, what do these have in common? I can pull out an 8, but remember that you want that sign also because you're going to end up combining these two. And 8x divided by 8 is x, and then 48 divided by 8 gives me that plus 6. So I drop down what they have in common, and I combine what is left over. So again, you notice that this one doesn't have a b value. So if I were to factor this, b goes at the bottom, 3 times 8 is on top. I want two numbers that multiply to give me the top, but that are opposite of each other to give me the 0. And again, you will notice that this is not factorable. And this here is your answer. If I give you a little shortcut, which you may have already noticed, why is it that this is not factorable, but this one and this one was? The first thing that you might want to notice here is that when I'm looking at these two things, the x squared minus 9 and then the x squared plus 6, the ones that were still factorable are subtraction problems. This one was an addition. Whenever you have a plus like this, it will not be factorable anymore. Another thing I want you to notice, though, is that the 9, this 4, and if I go back to the warm-up, the 16, they all have something in common. They are all perfect squares, which is why I was able to get the same number to be opposite so that it can cancel out, but still multiply to give me the top number. So if you want to check before doing all of this work whether or not something is factorable, check the sign, and that it is a perfect square. This is called difference of squares because you have that perfect square that you can swap the signs so that it cancels out. It's just a little shortcut. But other than that, that is our lesson for today. And that concludes 4.4.